So students, so in this lecture I will be solving numerical number 1 on bond, right? So what does it say? It says that for M20 grade concrete and Fe415 steel, the development length in tension, not compression, tension. For compression it increases by 25%, right? Is K times the bar diameter. It K times the bar diameter, where K is given by, use LSM, and top BD is given to you as 1.2 megapascals or 1.2 Newton per mm square. So very straightforward question. So I told you that the development length, it should be greater than or equal to sigma st into diameter of the bar divided by 4 times of top BD. I told you that, right? Now, what is sigma st? If sigma st is given to you in question, well and good. If it is not given to you, then you have to take the yield stress divided by the partial factor of safety. So what is the yield stress for Fe415? 415 Newton per mm square. And what is the partial factor for steel? That is 1.15, right? So you can say that 0.87 Fy, right? So if it is given, well and good. If it is not given, then sigma st is taken as 0.87 Fy. So we calculated for the maximum stress that can develop in steel, right? Now, so LD should be greater than or equal to, so K times the diameter. Let me take diameter and in a separate, you can say bracket, right? So it will be equal to sigma st. How much is sigma st? 0.87 Fy. 0.87 Fy is 415. 415 divided by 4 times of tau BD. How much is tau BD? 1.2 MPa. So 1.2 MPa. This is also Newton per mm square. Newton per mm square. No units into 5. So this is actually your K. So LD, we should be greater than or equal to K times of 5. This is K, and how much it is coming? So it is coming out to be, a lot of you must have got the answer also, 0.87 into 415 divided by 4 and divided by 1.2. It comes out to be 75.21. It comes out to be LD should be greater than or equal to 75.21 times the diameter of the bar. So 75.21 is the answer number B, which is the correct answer. So I hope that you have understood numerical number 1. Now let us move to numerical number 2. Thank you.